Part A. Write, but do not evaluate, an expression involving an integral that gives the perimeter of R in terms of K. So, for this, when we look at our given graph, which looks like so, what you're looking for is the perimeter, right here. So, we know this to be 1, this to be k, and this to be e to the 2k. However, we do not know the arc length of this arc. But we do have a function for this arc, and it is given as f of x equals e to the 2x, and this is not, no, that is k. So for arc length, we're going to need the derivative. So derivative f prime of x equals 2e to the 2x. So our expression will look as follows. 1 plus k plus e to the 2k plus integral from 0 to k for our arc length, and the equation 1 plus, using our derivative, 2e to the 2x, that quantity squared, which I cannot fit, but squared right there. So that is the expression. The region R is rotated about the x-axis to form a solid. Find the volume V of the solid in terms of K. So for this problem, we're going to need to find the rotated area, the area rotated, so it revolved around the x-axis. To do this, we're going to use our formula that we should hopefully remember of pi times the integral from our desired values, whatever our function is, squared in terms of x. So we know our function, and that is e to the 2x. So we're going to plug that in. Squared. Then we're going to plug in for a and b, our desired values, to integrate on. So we want 0 to k. K. 2x squared. And then integrate using k. So we're going to be left with pi integrating this value, which will leave us with pi over 4 e 4x, x equal to k, x equal to 0. So from here, I'm going to go and plug in k for x and then 0 for x. I'm going to subtract the two values. So plug in k, I'm going to get pi over 4 e to the 4k minus, plug in 0, pi over 4. That is our answer. Part C. The volume V found in Part B changes as k changes. If dk dt equals 1/3, determine dv dt when k equals 1/2. So for this part, we're going to need to look back to Part B using the function that we determined in terms of k, which was pi over 4 e to the 4k minus pi over 4. This is v. So for this, they're asking for dv dt, which means we're going to have to take the derivative of v. Then once we do so, plug in k as 1/2. So dv dt equals pi e to the 4k dk dt. because we took the derivative when k was our variable. So now we're going to plug in our values. So first, pi e to the 4, k is 1/2, and dk dt, which is 1/3 as given up here. 1/3. So reduce this down, we will end up with pi e to the 2 all over 3. And that's the final answer. One thing to note is the loss of the negative pi over 4 when you take the derivative.